Where's everybody today? Band get out late? What's going on?
I don't know.
Where is everyone?
May I have your attention, please? The band members came in late, so please admit them to the second period without a pass. Thank you.
Called it. Alright. I'm gonna say we have about half our class today. Jeez. Okay. Okay, if you have not grabbed a book yet, you need to go to the back, grab yourself a book out of the cabinet or out of the box that are on the floor.
Ben, I got you.
Grab yourself a book. If you have a book in your locker, or you know you have one, don't get a book. So you already have your book. So if you have one in your locker at home, that's your book, the one that you already have in your possession. So, all right, it's gonna be our official book checkout day. So I'm gonna have you walk up here. I'm gonna write your number in the book. I'm gonna stamp it. You don't need to worry about putting your name in it or anything like that because that's individually numbered. So we're gonna start with that first. Pretty straightforward, pretty easy. All right. Luke's gone right now. Brady, you're up first. So bring it on up. Perfect. And you are book number 2. Okay, there you go. This one. Alright. So welcome band people, welcome. Alright, let's see. Sam, you're up. Book number 3. And the stamper. There you go. Okay, Brown, you're up. Go grab yourself a book. If you already have one, bring it on up. You are book number 1. There you go. Okay, Bailey, you're up. Perfect. You are book number 4. There you go.
Alright.
Legit now. Okay, Cassie, you're up. Book number 5. There you go. Yep. All right, Trish, you're up. Book number 6. There you go. Okay, Rachel, you're up. Then it's Trevor. Rachel, you are book 7. There you go. Trevor, you're book 8. There you go. Okay. Michaela? Not here today. McKenna. Alright. So, let's see. McKenna, you're number 10. Alright. Yep. Yeah, we'll talk about that here in a minute. It's clear. Alright, and alright. Sadie, you're up. Good way to come in. Let's see. We're up to. Let's see. Riley, you up? You're not here. No. Okay. Let's see. Lucy. Riley's not here. Lucy. Okay, Lucy, you are number 12. There you go. Yep. Paige. Lucy, did I put 12 in your book?
Yeah.
Okay. Page, you're 15. There you go. Trinity, you're up. And then Rachel Sokol. Sokol even here today? No. You forget your keys in here this morning?
There's a book.
Trinity, 14. There you go. What was that?
Yeah, those are my keys.
Hannah. 6. There you go. Ben, you're up. Then James. Okay, Ben, you're 17. Okay, there you go. You were number 18, James. There you go. Yes. I do all my sports right-handed though, which is weird. Okay, all right. Hey, let's talk about this. Everyone's got their book now. We'll get you online copies next week. I'll just give you a little passcode. I think you've done that in other classes, perhaps. It's a little bit different for mine since it's a new company. So I'll get you the online version, so you don't have to lug this super heavy book around all the time. So it's your book. It's individually numbered. That means you can't go to the back and exchange it out. Can't do it. Okay, so don't lose it. Don't leave it in the lunchroom. Don't leave it in the band room and whatnot. They're like $120. Don't do it. They're brand new. I actually paid $160 for them so you could have an online version. So don't lose that book. Okay, this weekend, your first homework assignment. By Wednesday next week, that is the middle of next week, you need to have a book cover on it. Book cover. It's all or nothing. So it's what I mean by all or nothing. It's 10 points, whether you have it on it or not. So if you don't have it, you lost all 10 points and you don't get them back. So you'll already be failing the second week of geometry. And then you have to dig yourself out of an F. So it's 10 points all or nothing. And the worst part about getting a 0 on that is I'm still going to make you put one on there. And you still get 0 points for it. So get a book cover on it. Do it this weekend. I don't care what type of book cover on it. It could be a sleeve. It can be a paper bag for all I care. As long as it's on there. And don't come in here on Friday and tape a piece of paper to the top of it. That doesn't count. Don't pull that. Okay? Because I know somebody's going to try that. Oh, here's a little book cover. Yeah, it's a piece of paper taped to it. Doesn't count. Okay. Make sense?
Yeah.
Okay. They're heavy. I know that. Don't throw them in your locker. Don't just like launch it into your locker. Okay? You will break that book in half. It's super heavy and you'll bend your locker it'll just be a mangled mess in there. Okay? So take care of it. It's your book. Now you can take it home. You can take it wherever you want. Okay? Make sense? It'll be a lot easier for working on homework. I guarantee it. So, because we got a bunch in yesterday, they're still seeing those boxes down there. So that's good. Okay. So, let's talk about what we're doing today. We're going to go through some stuff here pretty quick, just to make sure we know how to cover it. We're going to cover the number line, the coordinate plane. That's the coordinate plane is where we left off yesterday. I believe we did a problem where we talked about the Pythagorean theorem, correct? We're going to continue with that today to show you how the weird formula I showed you earlier this week applies to the Pythagorean theorem. Then we're going to talk about midpoint today. That is our new formula. We have a new formula to find a midpoint of a stick. A line segment, a coordinate. Okay, there's two formulas for midpoint. Depends on what type of object you're given. We'll do a couple examples of each. And then, yes, you are getting homework today. You are getting homework and it's due next week. And guess what day it's due next week? Wednesday. That means you almost have almost a week, 5 days to actually work on it. Not 7. Okay? So you should have plenty of time to work on it. It is due Wednesday next week, right when you walk in. Not at the end of the day, not, oh, I didn't get it done. No, I don't care, it's due. Turn it in. Okay, that means you gotta take time to come in here Tuesday morning, Tuesday during class, Tuesday after school, Wednesday morning. And then when you come into my class, it's ready to go. That is your responsibility to figure it out. If you don't know it, I don't care, you didn't give me any effort. Okay, that's how it works. So, okay, let's talk about the number line real quick. I know that you're going to have a couple of problems today where you're going to have to find the distance on a number line. I just want to make sure you know the formula. So, -1, 1, 2, 3, 4, 5. So, any two numbers. Okay, it doesn't really matter. Let's say we're going -1 here to the number 5. And this is the line you're having. They won't tell you that. They won't tell you explicitly, like, you're trying to find the distance between -1 and 5. What they're going to ask you to do, and they're going to give you little letters above these. Sometimes they do this, or they give you letters. Sometimes they just have 2 letters there, just the ones above the -1 and 5. And they'll say in the instructions, find the distance from A to G, or find the length of AG, whatever that is. So number 1, you could count with your fingers, and I'm fine with that, and you could write down the number, how long it is. Or number 2, you could use the formula I gave you, because I know it's short and you can be able to find it, but if you have the formula, it doesn't matter about looking at the picture. So remember, the formula was this: you subtract the 2 numbers in any order you like, and then you put it in absolute value bars. That way it guarantees it's positive. That's how you do it. So you have to use the outsides. So it doesn't matter. I'm gonna go the 5 minus the -1, because it really doesn't matter. So 5 minus the other number, which is -1. The negative signs cancel out because it's a plus situation, because they make a plus sign. That's the definition of subtraction. And then so that makes 6. And what's the absolute value of 6? 6. That's right. That's what I'm looking for. That's the type of work I want to see in your homework. That. Right? Okay, now, on this particular problem, it doesn't matter the order you subtract, you're fine. Just make sure, like, if you're going to do the formula, fine. If you're going to count with your fingers, you're counting the gaps. So that's 1, 2, 3, 4, 5, 6 gaps. Question?
Do we have to put like
The actual form? No. You just have to, you gotta show me like what you're doing here. That way I can see where you went wrong. Maybe you thought 5 plus 1 was 7. You just made a simple mistake. Or, even worse, you're doing this. You know, you switched around, you were the person that put the -1 first, which is fine. And, you know, instead of writing a -6, which it should have been, because -1 minus 5 more is -6, and getting 6 out, maybe you're that person that saw this and went, oh, that's a 4. Well, no, it's not. So you missed a point there, because it's not 4, it's actually -6, because you just didn't see that. Okay. So just make sure you're giving me something I can grade. I want to see something there. Okay, is there any questions on the first type? Okay, I think you're going to have like 4 of those. I think you should be able to handle it. Okay, next part. They're going to give you the Cartesian coordinate system. There's going to have a couple where they actually have the graph already drawn, and they're going to have a couple where they don't have a graph. And I'll explain that here in a minute. So, let me give you a couple here. Okay, this is 1, 2, 3, 4, -1, -2, -3, -1, -2, -3, -4, 1, 2, 3, and 4. All right, so here's your coordinate system, x, y, you know, coordinate plane, whatever you want to call it, and they're going to ask you to find distance between 2 points that are on it. They could be anywhere. They could be straight across, they could be up and down from each other. Those are easy if they're straight up and down or straight across, because you can just count. But if they're at a diagonal, that's when you have to use like the Pythagorean theorem, or you have to use the other formula, which I showed you earlier this week, but I'll show you how they're related to each other. So the idea here is that it doesn't matter what coordinates we pick. Let's say I pick this coordinate, so that coordinate is, let's call this C, and I'm going to pick a coordinate up here. Let's pick this one. That's going to be D. And their question is find CD, like find the length of it. That's the question. Okay, And I know that they always have it, you know, these first, I think the first three of them that you have, they're drawn. They're drawn like that. They want you to find that length. Okay, so to do that, you have to know the coordinates. And sometimes they list them off to the side, where C is a -2, -3, and D is a 3, 1. They have it listed off to the side sometimes. Sometimes they have it just drawn on the actual picture. So it just depends on which problem you have. You have to be able to find the distance. That's where you have to use the Pythagorean theorem. Like, it's just essential that you do that. Pythagorean theorem works like this. You have to count the horizontal number going across, and you have to count the vertical number going up and down, so that you can set up your triangle. Because remember, the Pythagorean theorem, if you don't remember from yesterday, is this. That's the Pythagorean theorem. A squared plus b squared equals c squared. Okay? Now, where the a and b numbers come from? The a and b number is literally the green sticks on that picture. It's the stick going up and down, and the right and left number. It's the two walls that touch the 90-degree box. That's your a and b number. The c number is the wall you're trying to find. That's what you're trying to do. Okay? So, you need to plug in those numbers, like the lengths of those sticks. So, what I usually do is I just kind of look at, you know, I transfer these numbers down these little hash marks. So then I can count how many spaces there are. Because that's why I like to transfer the marks down, so I can count 1, 2, 3, 4, 5. So this wall here is 5 in length. So I can put a 5 in there for the A. The wall going up, transferring these marks across. That wall is 1, 2, 3, 4 in height. That's a 4. There's 4 actual gaps there. So that's 4 squared. And now I can solve for C. C is the wall I'm trying to find. Okay, and so did everyone see where I got the 4 and the 5 from? Like actually looking at the sticks going up and down versus right and left. And now, once I have that, now I can solve, because 5 squared, how do we do that? What does 5 squared mean?
5 times.
Okay, good. 5 times 5. So it's 5 times 5, which is 25. The 4 squared?
16.
Yeah, so 4 times 4, that's what the square means. You take it times itself, so that's 16. And then we're going to solve for c squared. And this may not be a nice number. It might be a weird kind of quirky number. We'll see if it's a decimal or not. So, the idea here is when I add these two together, I get the number 41. And I take the square root to the other side. So if because the power of 2 is over here, you don't divide by 2. You just take the 2 to the other side and you do the square root. So this can be a decimal. It's guaranteed. How I know it's a decimal? Because I'm trying to think of two numbers that multiply together to give you 41. 41 is not a nice number. It's just not. So the idea is I know the decimal of that number is going to be between 6, because 6 times 6 is 36, and it's between 7. 7 times 7 is 49. So it's right between 6 and 7 as a decimal. So I'm going to leave my answer like that. Does that make sense? So it's between 6 and 7 as a decimal. Okay, does that make sense how you can leave it? That's what I want. That's like the correct answer. That's the correct length of that red stick over there, C to D. Now, here's the thing. I know that some of the problems won't have the drawing. Like the drawing is easy. I can count with my fingers, you know, what the lengths of those were. If you don't actually have the drawing of it, you can still do this formula, okay? And the formula is based on this. This is the distance formula I gave you earlier this week. I don't know if it was, I think it was maybe Tuesday this week, maybe I gave you the formula. It was this weird thing where it was x minus x squared plus y minus y squared. And I think I hinted at it on Tuesday. It was just like the last 5 minutes of class we talked about what it is, what we're going to be going into. This looks complicated, correct? It looks difficult. It's the same problem you had there. It's literally the Pythagorean theorem, just written differently. This big square root symbol, actually, if I take this big symbol here to the other side, that would be d to the power of 2, which is this. It's the distance you're looking for. Then you have an a number that's squared and a b number that's squared. It's still the Pythagorean theorem. It just looks really complicated. how it works is when you go to your coordinates over here, do you see your coordinates? You're just subtracting those numbers. And that's the numbers I'm plugging in here. So for instance, on these two coordinates, which numbers are the x numbers? Yeah, the left side, right? It's alphabetical order. The y numbers are the right side, right? That's how an ordered pair works. A coordinate, it's always alphabetical order. That's why they call them ordered pairs. That's what I plug in here, and it will give me the same answers that you're looking at right there. It's going to give me the same problem. So that's why I don't need to look at the picture. If I have this formula, I can just plug in the numbers. So I'm just going to take those numbers for C and D. I'm going to take the x numbers, the 3 and the -2 number, the x numbers here. I'm just going to subtract those right here. And it doesn't matter the order. I'm going to go the top number minus the bottom number. So -2 minus the 3. Okay, that's my 2x numbers being subtracted. So that's that number minus the bottom number. Okay, that's what I'm doing here. And then I'm going to add, and I'm going to do the y numbers, top minus the bottom, -3 and the 1. -3 minus the 1. Okay, does everyone see how I'm doing that? Taking the y numbers and subtracting? I just pick an order. So when I stack them, I just pick top minus bottom. That's how I do it. And this is going to give me the same problem you're just looking at here. It's actually giving me the exact same numbers, in fact. Because this number, -2 minus 3, is a -5, and I'm going to square it. And then over here, this is -3 minus 1, which is a -4, and I'm going to square that. And I'm going to put a square root symbol around it. Well, here's the thing. When I square negative numbers, what do you get? Positive, because it's going to be a -5 times a -5, which is positive 25. Positive, because the negative signs cancel out. -4 times a -4, which is a 16. Well, guess what? That's what you're looking at there. It's the same problem. And then you eventually get the 41. So you see how you can use this? Some people really like this. They have the formula, they just plug in the numbers, it spits out an answer, you move on to the next one. This idea of the Pythagorean theorem, you have to think about it a little bit. You have to like look at the picture and kind of count, you know, how many over, how many up you're going. If you don't like looking at the picture, maybe you're not really good at counting, maybe this is the way to go. You just have to know how to subtract, basically. Okay, is there any questions with that? Okay, if you haven't already, I would definitely write down the Pythagorean theorem if you haven't already, and I would definitely write this down so you know how to do it.
What's that formula called?
It's called the distance formula. It's actually a distance formula for a coordinate plane, as opposed to just calling it the Pythagorean theorem. This is the formula that we'll use in Algebra 2, we'll use this in pre-calc, we use it in a lot of the upper level math classes because I don't resort to drawing pictures a lot. We just fall back to this. Okay, any questions with the two formulas? Now, here's my question to you. Do you want to go through one more example of that?
Yeah.
Yes, okay, let's do one more. Do you want to do distance or you want to do Pythagorean theorem?
Distance.
Distance formula, okay. Let's make up any coordinates we want, okay? So I'm just gonna ask one of you to make up a coordinate, we'll make up a different one, we'll plug it straight into that formula so you can see exactly how it's gonna look, okay? I think everyone's good with this, correct? Okay, good. This one's easy, just doing that stuff. Okay, so let's do another one, just like that, but instead of drawing a picture, we're just gonna give you coordinates. So, example, we're gonna go with G, that's gonna be one of my coordinates, and we're gonna go H, my other coordinate. Now, let's make up some numbers. So somebody raise your hand, let's give the coordinate. Boom. First. 6, comma?
-1.
-1, I like it. Somebody else now, throw out numbers, I don't care what they are.
-4.
-4, comma?
5.
5, alright. We comfortable so far? Let's plug it into the formula over there, because I don't want to draw the picture here. I want to avoid the picture altogether. I don't even want to look at it. I'm just going to take these numbers and plug it into that crazy distance formula over there to figure out how long this thing is. So, x minus x squared plus the y minus the y. Okay, that's my distance formula. So the x numbers. That's the numbers out front. These are the x's. Remember, it's always alphabetical order. The x's are the front numbers. The y's are the back numbers. That's how they work. I'm going to take top minus the bottom. That's just how I always do it. So, because that way it's easy. It's consistent every time. 6 minus the -4. 6 minus the -4. Okay. plus, now I'm going to subtract the y's. The y numbers are -1 minus the 5, top minus bottom. Everyone see the setup. You always subtract, plus signs in the middle of everything. So what happens to these two negative signs?
And positive.
Yeah, so this is actually 6 plus 4. And back here, this makes -1 minus 5 more is what? -6. We're going to square that. So right now I have 10 squared plus that -6 squared. 10 times 10. 100. 6 times 6? 36. And so we get 136, and we're going to take the square root. That'll also be a decimal. How I know that? If you think about it, it's like, what is 12 times 12? 144. So it's definitely not 12. It's too small. 12 times 12 is 144. So that number's smaller than 144. So it's not 12. 11 times 11 is 121. So it's not 11 either. It's right between 11 and 12 as like a decimal. Okay. All right, but that's the answer. That's what I want. That's the distance. It's 11 point something, 11.7, let's say. I don't know. So, but that's what you can leave it as. That's the exact answer. I wouldn't want to draw that. It's really long. I don't want to look at that. I mean, if you did this formula where you did the Pythagorean theorem, you count it over and up, you'd get the same answer. Get the square root of 136. Doesn't matter. Okay. We comfortable with the distance formula and or drawing it? Okay, not bad. Okay, last thing today. You got to talk about midpoint. Midpoint. How do we find the middle? That's what a midpoint is, right? Midpoint, middle point. How do we find a midpoint of a stick? The middle of it. Well, middle is an average, right? It's like the median. It's the middle of something. So that's what we're going to do. To find a middle of something, we're just going to do an average of things. So this will be my last example of today. We'll do a midpoint of a line segment, and we'll do a midpoint for a Cartesian coordinate plane. So 1, 2, 3, 4, 5, 6, 7, 8. So 0, 1, 2, 1, 2, 3, 4, 5. All right. So this is number one, right? Any two numbers, please, on that. And 2 and 2 and -2. Okay. So this is, let's call this x. Let's call this y. Okay, those are my two dots. I want to find the middle of them. Well, common sense. You can look at the picture and see the middle. What's the middle? 0. That's what they want. So the question will be, find the coordinate. Find the coordinate of the midpoint. Coordinate means they want the actual number, like you guys said. It's 0, right? That's the middle of -2 to 2. It's right purple in the center of it. Most people are very visual. They can see that. Okay? That's great. What if you didn't have the drawing? If you didn't have the drawing in front of you, you just knew that x was -2 and y was a 2. No. You average them. Because what a mean or a median is in algebra class, like especially a mean, you add them together and you divide by 2. That's how you find a middle number. You add up all the entries, you divide by 2, that's an average. So, -2 plus 2, that's adding them together, and then you divide by how many different numbers did we have? We had 2 numbers. That's how you do it. You always divide by how many numbers there are. You always divide by 2, basically. And we get the average. Well, what's -2 plus 2? 0. And we're going to divide by 2, which is still, that's the coordinate for the middle. You average them. Now, the best part about seeing that's exactly the same formula that we're going to do, but for the Cartesian coordinate plane. To find the average. To find the middle of a coordinate plane, we can do the same thing. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so on a coordinate plane, Same exact idea. In fact, I'm going to use the numbers you guys created over there. The 6, -1, I like those. So 6, -1, all right, here's G. And H is -4, 5, so -4, 5 up here. So there's H. And I want to find the middle of that thing. Well, the middle is somewhere in here. Somewhere like right there, like the middle. But I want the coordinate for it. Now the weird part is it could be a decimal. I mean, I could have got a decimal in that last problem. Could have been a half somewhere. But how do we find the middle? So that's where you do the average. It's just like what you've seen here. But we're going to do it for both the x and the y coordinates. So the coordinates that we had here earlier, this was 6, -1. And this point was -4, 5, right? We're just going to average those coordinates together. So what I mean by that is you're going to figure out the coordinate for the midpoint, I'm going to label that with an M, the coordinate for the midpoint, you're going to just do the same formula. So you're going to take the x numbers. What are my x numbers up here? -4 and 6. You're going to add them together, divided by 2. -4 plus 6 and divide by 2. That will give you the middle of the x coordinates. And then we're going to do it for the y's as well. The y numbers are 5 and the -1. We're going to add those together and divide by 2. That's how we find the middle of them. That's like the perfect middle. And if we do the middle of both, that's the midpoint of the stick. Because it's going to average them together. Because how that works, why it's going to give me the middle. It's finding the average of the x numbers, so that'll find the middle. And when you find the average of the height, it'll put you right back on the line again. That's how it's going to work. So this number is going to turn out to be -4 plus 6, what is that, 2? And you divide by the number 2. So the midpoint will definitely be 1. 2 divided by 2 is 1. 6 plus a -1, what is that, 4? And we divide it by 2, which is 2. So it's 1 over 2 up. So this is actually where the line should have been. It should have been right there. So I have it drawn a little bit wrong, but there you go. Okay, so does everyone see how that worked? How I figured out the coordinate for the midpoint? That's what you're going to have to do. This is like the formula that you just average the two numbers together. Okay, your homework today will be asking you to find distance on a number line, define distance on a Cartesian coordinate plane, so you can use this formula if you wanted to, define midpoints. Like that's what they're doing. Now there's one extra problem that I'm not going to talk about. I want to see how you solve it. And then we'll come back on maybe Tuesday or Wednesday and we'll talk about it. Okay? Alright, remember, you have the weekend to work. I know you only have about 7 minutes right now. 7 minutes, but that's fine. You can work, you have a book, you move around and stuff. Here's your homework problems. And trust me, you're going to want to take your book home. Alright, so here's your homework. It is page 31, 13 through 16, 22 through 27, 33 through 36. I just kind of bounced around a little bit. 40 through 46, the evens on those. So there's only about 3 of those. 47 through 50. And the last ones are 53 and number 54. And those two, 53 and 54, are the ones I have not talked about yet. They're the ones I want to see how you would solve them. So it's kind of bounced in little pairs. So it's one of every type of problem, basically. I mean, you're going to have a couple where you find distance on a number line, distance on a coordinate plane, find a midpoint on a line, find a midpoint of a coordinate plane, kind of a mixed bag of everything, and then the last two are challenge questions. How well can you do those problems? Okay. You can move around, you can start. Pretty straightforward. Remember, read the instructions so you know what they're asking you to do. Maybe you have to find distance on the number line or something. And then just do your normal formulas. Pretty straightforward, don't overthink it. Okay, if you, remember, if you were gone for the ag trip, at some point today, or actually I even told it to everybody, at some point today, if you were not done with that last assignment, page 18, that was the one that was due yesterday. If you didn't get it done, it's due today. Make sure it's done. Get it turned in. Hannah, I just got your email like 10 minutes ago. So if you need to come in and stuff after school or something, you can do that too. So sorry, I didn't even check your email until this morning. Okay, just a reminder, we do have a Pep Assembly today. That's at the very end of today. So all classes in the morning are all normal times. It's after the lunch period, so period 6, 7, 8, 9. They take about 3, 4 minutes off. That's all they do. So the bell system should work today. They'll have it all kind of fixed and corrected. So there you go. Just a reminder, because we got about 30 seconds here. What's your homework for Wednesday? Book cover and this assignment. Take it home. Okay? If you borrowed a calculator from me, make sure I'm getting those back. Some people borrowed a calculator earlier this week. I need those back, please. Question?
Olivia Giener, please come to the office. Olivia Giener.